Yes, so let's begin. Topic is a spanning tree protocol. STP. STP stands for spanning tree protocol. It is a layer 2 protocol, guys. It is a layer 2 protocol. What do you mean by layer 2 protocol? What is the meaning of it? If I'm saying it is a layer 2 protocol, it means what? Very good. Same answer I was expecting. STP will generate their all messages at layer 2 at data link layer. Fine. And basically we have only two types of message in STP. So always keep in mind, whenever we will connect switch in loop, then guys there will be MAC flapping. There will be broadcast storm. Broadcast storm, or you can say MAC flapping, right? Or you can say layer 2 loop. So to overcome this issue, to solve this type of issue in the network, we come up with a spanning tree protocol, right? So like here also you can see switch 1 and switch 2, both switches are in loop. So loop can form in the topology whenever a PC will generate broadcast message. Whenever a PC will generate broadcast message in this scenario, loop will form. How loop can form? If PC1 is generating a broadcast message, let's say ARP message, how loop will form, guys? Switch 1 is going to forward that broadcast message from both interface to switch number 2, right? And switch 2 will receive broadcast message on one interface and it will forward from the another trunk port, from the another trunk link. Like if it is receiving broadcast message on 0/1, then it will forward from 0/0. If it is receiving broadcast on 0/0, it will forward from 0/1, right? So you will see the MAC address is flapping between multiple ports on the switch in this scenario. That's why we come up with STP. Yes. Okay, so to avoid loop in this scenario, we come up with a spanning tree protocol. Now see what a spanning tree protocol will do. To avoid loop in this scenario, first of all, a spanning tree protocol is going to perform root bridge election. Now question is, what is root bridge? Correct. So anyone who have idea about the root bridge? There are some terminology in a spanning tree protocol. First we need to understand those terminology, then only we can understand the spanning tree protocol, like how STP is avoiding loop. So the first term is root bridge. What is root bridge? So I'm saying to avoid layer 2 loop in this scenario, we come up with a spanning tree protocol. A spanning tree protocol is going to avoid loop here, and to avoid loop, STP will perform root bridge election. STP will perform root bridge election, right? Root bridge is nothing but, you can say, the reference point in network. The main switch, one switch will become the main switch, and that main switch is known as root bridge switch. There are some terminology in spanning tree protocol. To understand how STP is avoiding loop, you have to understand those terminology, right? And the first term is root bridge. So anyone have idea what is root bridge? Anyone have idea, guys, what is root bridge? So root bridge is the reference point, or you can say the main switch. Now question is, out of switch 1 and switch 2, which switch will become root bridge? So the switch who will have best bridge ID, that switch will become root bridge. Now again another question, what is bridge ID then? So guys, bridge ID is combination of two things. Number one is base MAC address, and second thing is priority, right? You know, all switches has one base MAC address. So switch 1 will also have one base MAC address, switch 2 will also have one base MAC address. Let's say base MAC address of switch 1 is 0A and base MAC address of switch 2 is 0B. And the priority is by default same on both switches, right? So guys, root bridge ID is nothing but base MAC address plus priority. By default priority on switches is 32768 on both switch 1 and switch 2. So what will be bridge ID of switch 1? Bridge ID of switch 1, 32768 plus 0, 0A. Very good. Bridge ID of switch 2, 32768 plus 0, B. So switch 1 has bridge ID 32768 plus 0A, and switch 2 has bridge ID 32768 plus 0B. Now tell me which switch has lowest bridge ID. Switch 1, this one is the lowest, so switch 1 is going to become what? Root bridge. Switch 1 is going to become root bridge, and root bridge switch is going to decide which port will be in forwarding state, which port will be in blocking state. See how a spanning tree protocol is going to avoid loop, guys. A spanning tree protocol is going to track the loop in the network. It will be keep tracking the loop, right? And it will put the backup path, the redundancy link, in the blocking state. Why we have connected two link between switch 1 and switch 2? For the redundancy, for the backup. So if one link will goes down, then also we can have connectivity between switches. That's why I have added two link. But if I am adding two link, then there is loop. So a spanning tree protocol is going to track the loop, right? It will be keep tracking the loop, and it will put the backup port in blocking state. Now which port will be in blocking state, which port will be in forwarding state, will be decided by root bridge switch. Will be decided by root bridge switch. Okay. So if someone will ask you like, what is a spanning tree? Right. So a spanning tree is a layer 2 protocol which is used to avoid layer 2 loop. Question is how? So a spanning tree protocol is going to detect the loop in the network, and then it will block the certain port, backup port. And guys, if someone asks you like how a spanning tree protocol works, so a spanning tree protocol is going to perform some election, right? The first election is root bridge election, right? In the root bridge election, one switch is going to become root bridge, and all other switches are going to become non-root bridge switch. Now question is which switch will become root bridge? So the switch which have lowest MAC address, that switch will become root bridge. What is the bridge ID? Switch who will have lowest bridge ID, that switch will become root bridge. And bridge ID is nothing but the combination of MAC address, base MAC address, and priority. Don't worry about the priority, we will discuss priority later. What is the range of priority? So in my scenario, switch 1 has lowest bridge ID, so switch 1 is going to become root bridge. Now guys, all non-root bridge switch are going to calculate best path to reach root bridge. Like switch 2 is non-root bridge switch, so non-root bridge switch is going to select best path to reach root bridge, right? There are two paths. There are two paths to reach root bridge, switch 1. So it is going to find which path is the best, right? If my scenario is like different, switch 1, this is the most common topology in a spanning tree protocol. Even you can find this topology in your book, on the internet, everywhere you will see this topology. Switch 1, switch 2, switch 3, connected like this. Switch 1, switch 2, and switch 3. Switch 1 has, let's say, MAC address 0A, 0A. Switch 2 has MAC address 0B, and switch 3 has MAC address 0C. Now you tell me which switch will become root bridge switch? Switch 1 will become the root bridge. So now root bridge is switch 1. Now how many paths are there from switch 1 to reach root bridge? This is the root bridge. Root bridge. Now all non-root bridge switches are going to find best path to reach root bridge. Non-root bridge switches means switch number 2 and switch number 3. So if switch 2 want to reach root bridge, how many paths is there? 2 paths, right? In the same way, switch number 3 have how many paths to reach root bridge? 2. Out of the 2 paths, it is going to find the best path. Which one is the best path? So guys, the second election is best path selection, right? First election is root bridge election. One switch will become the root bridge, right? Then all non-root bridge switches, mean switch we can say, or we can say the reference point in the network. The second thing is all non-root bridge switches are going to find best path to reach root bridge. Now how non-root bridge switches are going to find best path to reach root bridge? So guys, with the help of cost, with the help of cost value. Anyone have idea about the cost? Like what is cost? Don't worry, we are going to discuss cost soon. Till then, first of all, tell me. Yeah. 19 is the cost of fast Ethernet port, fast Ethernet link. Cost on the Ethernet link is 100. Cost on fast Ethernet link is 19. Cost on 1 gig link is 4, and cost on 10 gig link is 2. Let me write here. And you cannot say like Ethernet cost. You can say cost on the 100 Mbps link. 100 Mbps link cost is 100. On the on 10 Mbps cost is 100, and on 100 Mbps cost is 10. On 1 gig cost is 4, and on 10 gig cost is 2. So actually cost is inversely proportional to bandwidth, right? Guys, Cisco have never revealed the formula, like how they are calculating the cost value. There is no any formula. We cannot calculate the cost on the link, right? But we can see the cost is inversely proportional to the bandwidth. If bandwidth is 10 Mbps, then cost is going to be 100. If bandwidth is 100 Mbps, then cost is going to be 10. If the bandwidth is 1 gig, then cost will be 4. And if bandwidth is 10 gig, then cost is going to be 2. Any question in root bridge? Is root bridge clear to all? For avoiding the loop in the network, all switches are going to perform root bridge election first. In the root bridge election, one switch will become root bridge, right? The switch which will have lowest bridge ID, that switch will become root bridge. And all non-root bridge switches are going to find best path to reach root bridge. So sometime in some book you will see the definition of root bridge is a switch which has best bridge ID. Best bridge ID means the lowest bridge ID will become root bridge. And bridge ID is combination of two things. Bridge ID, base MAC address, MAC address plus priority. Plus priority. Guys, priority is nothing but 16 bits decimal value. So range can be 0 to 65535. This is the range of priority. And you know the base MAC address. Base MAC address is, what is the length of base MAC address? 48 bits, right? That means 6 bytes. So in my scenario, switch 1 will have bridge ID 32768, which is the default bridge ID, plus base MAC address, which is 0. This is the bridge ID of switch 1. Bridge ID of switch 2, 32768 plus 0B. And bridge ID of switch 3 is 32768 plus 0C. So as switch 1 has lowest bridge ID, switch 1 is going to become root bridge, and non-root bridge switches are going to calculate best path to reach root bridge. Now, to understand the cost, try to understand BPDU. Guys, second terms in the spanning tree protocol is BPDU. BPDU. And BPDU is nothing but the hello message of spanning tree protocol. Like switch number 1 have become root bridge. Now, how switch 1 has become root bridge? Definitely these switches has exchanged some messages, right? So actually these switches have exchanged this message, BPDU message. BPDU stands for Bridge Protocol Data Unit. Bridge Protocol Data Unit. This is a hello message. You can say after every 2 seconds, root bridge switch sends BPDU. But for the first time, when these switches will come up, all switches will think I am the root bridge. All switches will think I am the root bridge. So all switches are going to generate what? BPDU. Right? But on switch 2 will receive BPDU of switch 1. It will get to know, no, my bridge ID is not the best. Switch 1 has lower bridge ID than me. That means I am not the root bridge. switch 2 will declare their self as non-root bridge switch. In the same way, switch 3 is also going to declare their self as non-root bridge switch. So once root bridge election happened, after that only root bridge switch is going to generate BPDU after every 2 seconds. So if someone asks you like what is the use of BPDU, so you can say BPDU is used to elect root bridge in the network. It is used to elect root bridge in the network. And BPDU message carry bridge ID, right? Bridge ID. Then only switch 2 will get to know the bridge ID of switch 1 on switch 3. In the initial, when these switches will come up, all switches will send their BPDU. Switch 1 will send their BPDU to switch 2 and 3. Switch 2 is going to send their BPDU to switch 1 and switch 3. Switch 3 is going to send their BPDU to switch 1 and switch 2. And in their BPDU, they will carry this information, their bridge ID, right? And there will be many more information. We will see the content of BPDU, but the most important information is bridge ID. Fine. So for the first time, all switches are going to send BPDU, but once a switch will receive superior BPDU means again best BPDU. Best BPDU means the BPDU where we have lowest bridge ID. So now switch 1 is the root bridge, but let's say here I am connecting one new switch. Here I am connecting one new switch, and priority over here is on the new switch is 0. Priority on the new switch is 0. So guys, which switch will become root bridge now? Definitely new switch, right? So once new switch will come up, it will think I am root bridge, it will generate their BPDU. It will forward to switch 1. On switch 1 will receive the superior BPDU, the best BPDU. Switch 1 will declare theirself as non-root bridge switch. It will declare theirself as non-root bridge switch. So always keep in mind, whenever a switch is receiving BPDU with lower bridge ID, it will declare theirself as non-root bridge switch, right? And there are two types of BPDU. One is types of BPDU. Types of BPDU. So we have two types of BPDU. First one is the configuration BPDU. Configuration BPDU. And the second one is TCN BPDU. TCN BPDU. We'll talk about TCN BPDU later. For now, just understand configuration BPDU. Guys, TCN, topology change notification. Whenever change will occur in the topology, in that scenario, we are going to use TCN BPDU. Right? If network is stable, then you will not see TCN BPDU. There will be only configuration BPDU. And who is sending root bridge switch after every 2 seconds. To see the information inside the BPDU, what we can do, we can capture the link, right? And before capturing the link, we have to identify which link is in forwarding state, right? So on switch number 1, we can run command show spanning tree. Enable show spanning tree. Now guys, this is the information of what? Root bridge. And this is the information of what? Bridge ID. They are on bridge ID. Right? So priority is by default 32769. This is not 9. This is the reason is different, right? We will discuss it later. By default priority is 32768 only. Actually, we have multiple types of spanning tree protocol, and here we are running PVST, per VLAN spanning tree. So here actually it is adding VLAN ID with priority. So for VLAN 1, it have add VLAN ID 1. Then guys, see the root bridge information. Priority is this one, and the base MAC address is this one. And what it's saying, this bridge is the root. That means this switch is the root bridge switch, right? And hello time is 2 seconds. Max edge time is 20 seconds, and forward delay time is 15 seconds. We will discuss about these timers later. And then the bridge ID information. So as this switch is the root bridge, means their bridge ID and root ID both will be same, correct? So you can see the base MAC address is exactly same, right? But on the switch number 2, guys, we will have information about the root bridge ID, right? Their MAC address will be the MAC address of switch 1, right? And in the bridge ID, their on information, switch 2 information, right? So let me access switch number 2 here. And on switch number 2, I can say show spanning tree protocol, show spanning tree. Fine. So see here, both information are different, right? Bridge ID is this one, and the root bridge ID is this one, and the bridge ID is this one, right? Bridge ID, see the MAC address of switch 2 and the MAC address of root bridge. Priority is again same. This is the MAC address of root bridge ID, root bridge switch, and this is the bridge ID of local switch, right? And are you able to see the blocking port over here? 0/1 is in blocking state. Blocking. Port role is alternate, and the state is blocking. So I'm going to capture 0/0 interface on any switch we can capture, because my root bridge switch means switch 1 is keep generating BPDU. The spank tree message, see here, let me open any spank tree message. See, the information is at which layer? At layer 2, right? Then Ethernet header. So let me open it. First information is, guys, protocol identifier, which will identify the protocol, right? We have multiple layer 2 protocol like VTP, DTP, CDP, LLDP. Those were layer 2 protocol. Those were layer 2 protocol. And after that, protocol version. Then BPDU type. So as I told you, there are two types of BPDU. It can be configuration BPDU or it can be TCN BPDU. So don't worry about these information. These informations are not important for you, like protocol identifier, the protocol version, and the BPDU type. Even BPDU type is important. What rest informations are there? Root bridge identifier, right? Root bridge identifier. And see, guys, what is the priority over here? 32768 plus VLAN ID and then base MAC address. Base MAC address of switch 1. And the cost is 0. So always keep in mind, root bridge will always generate BPDU with 0 cost. And non-root bridge switch will add their receiving interface cost in the BPDU. Fine. So BPDU is going to carry these all information like root bridge identifier, root port cost. Root port cost means the cost from where it is forwarding the BPDU. Then, guys, bridge identifier means the local bridge ID. Then message time is there, hello time is there, and forward delay time is there, right? We'll discuss these 3 timers later. All clear? Any question in the BPDU message? Protocol ID is saying, protocol ID is actually 2 bytes information which will identify the protocol, then version, then type. Type can be configuration or BPDU. After that, flag field is also there. We'll discuss flag later. So there are 2 types of flag, 2 bits are there. In the PVST, you are able to see only 2 types of flag, but we have multiple types of spank tree. We will see we have many more flags as well. Then, guys, there is information of root bridge, right? Like the priority of root bridge switch, the system ID means VLAN ID, then the base MAC address of root bridge. After that, cost to reach root bridge. So cost to reach root bridge from the root bridge is 0. Yes or no? Cost to reach, distance to reach your home from your home is what? Always 0. Then the bridge ID means local information. Fine. So root bridge always generate BPDU with 0 cost. So now switch 2. Let me open the epic. Yeah, switch 2. Switch 2 will receive BPDU of switch 1 on 2 port, on this port also and on this port also. Fine. And guys, root bridge will generate BPDU with cost 0. Here also it will generate BPDU with cost 0. When switch 2 will receive BPDU on this port, it will add the cost value. So as I told you, see cost, this is let's say fast Ethernet link or Ethernet link, then cost is 100, right? So what will be cost to reach root bridge from this port? 100, right? Now when switch 3 will receive BPDU from switch 1, again it will add their cost 100, and then this switch is going to relay that BPDU to switch number 2 with cost what? 100. In the BPDU which switch 2 is receiving from switch 3, cost is 10, and it will add their receiving interface cost. So total cost will be what? 200. So from this path, total cost to reach root bridge is 200, and from this path, total cost to reach root bridge is 100. So you tell me which path is the best? Lowest value is the always prefer value. So the best path is this path, right? This path. So this path will become best path to reach root bridge. All clear? This path is the best path to reach root bridge. From switch number 3, again switch number 3 is receiving BPDU on 2 port. On this port, cost will be 200, right? So best path is this one. So both non-root bridge switches have elected the best path to reach root bridge. Now guys, I have another scenario like this. I have another scenario like this. Okay, I have already scenario here. Yes, in this scenario, switch 1 is the root bridge. So switch 1 is going to forward BPDU from this port also, and BPDU from this port also. Now tell me how switch 2 is going to elect best path. Which link is the best link to reach root bridge? So if cost will tie, in this scenario, what will happen, guys? On both port, cost is same, 100, 100. If cost will tie, then it is going to check what? Cost over here 100, cost over here is also 100. So cost on both link is 100. Then it is going to check what? Port ID. Now to understand the best path selection, you need to understand STP port ID, right? So the next term is STP port ID. Again, STP port ID is combination of two things. STP port ID is combination of two things. First one is port priority. Port priority plus interface ID. So the first information is, guys, here port priority of port, and then interface ID. And by default priority of port is 128, and interface ID is, you can see this one like 0/0, 0/1. These are what? Interface number. These are what? Interface number. So let's suppose I have one switch here, one switch, and this switch is receiving BPDU on two port, switch 1, and this switch have two port, let's say 0/1 and 0/1. On both port it is receiving what? BPDU. One BPDU over here and one BPDU over here. See how this switch is going to find the best path, right? Where I am receiving the superior BPDU. You can say topic is identify how to identify superior BPDU. Where on which port I am receiving best BPDU, superior BPDU, best BPDU, or you can say the lowest BPDU. For that, switch is going to first check what? Switch is going to check first what? Lowest bridge ID. Lowest bridge ID. Right? We can say lowest root bridge ID. Lowest root bridge ID. So guys, let's say this port 0/1 port is connected with another switch, and this port 0/2 port is connected with another switch 0/2, right? So the switch which is connected with 0/1 here have the MAC address, let's say 0A, and the switch over here MAC address 0B. So bridge ID over here will be what? 32768 plus 0A, and bridge ID over here will be 32768 plus 0B. So on which port switch 1 is receiving superior BPDU? On 0/1 or on 0/2? 0/1, right? So this port will become best port to reach root bridge, right? But if both ports are connected with a single switch, in that scenario, bridge ID is going to be what? Same, right? Then it will check what? Cost, right? If the root bridge ID is same, then switch will calculate cost. Fine. Now try to understand this port 0/1 port is connected with one switch here, right? But 0/2 is connected with one switch here, and this switch is connected with another switch like this, right? Here MAC address is 0A, here MAC address is 0A, here MAC address is 0A. By the way, this is not possible. This is not possible. But let's say, let me correct it. The scenario is incorrect. Switch to 0A MAC address. Here I have another switch, 0C MAC address, 0B MAC address. This is connected like this, right? So in this scenario, 0/1 is receiving BPDU over here and BPDU over here. Root bridge ID is same, right? 32678 plus 0A. In the both BPDU, root bridge ID will be same, right? Then it will calculate the cost. So cost over here will become 100 and cost over here will be 200. So on the basis of cost, it will find best port to reach root bridge. But if cost is also tie, the second thing is definitely we check cost. And guys, if cost is same, then if cost is same, then it is going to check lowest designated bridge ID. Lowest designated bridge ID. Then it will check lower designated bridge ID. Designated bridge ID means sender bridge ID, you can say. The sender bridge ID. Sender bridge ID. Clear? What do you mean by this? See, here I have one switch. Here I have one switch. Here MAC address is 0B. Here MAC address is 0C. And here I have one switch where MAC address is 0A, connected like this. In this scenario, root bridge is this switch, right? It is forwarding BPDU here, it is forwarding BPDU over here, right? Root bridge ID is going to be, guys, same. Cost is also going to be same. Then it will check what? It will check sender bridge ID, right? So when this switch 0B will forward the BPDU, root bridge ID will be 32768 plus 0A, but sender bridge ID will be what? 32768 plus 0B. In the same way, when this switch 0C will send BPDUs, root bridge ID will be same, 32768 plus 0A, but sender bridge ID will be 32768 plus 0C. So tell me, switch 1 is receiving superior BPDU on which interface? 0, 1, right? And switch is selecting best path on the basis of sender bridge ID. Sender bridge ID, designated bridge ID, you can say. Fine. But if sender bridge ID is also same, here we have switch 0A. In this scenario, cost is also same, root bridge ID is also same, and sender bridge ID is also same. So guys, the third thing is sender bridge ID. And if sender bridge ID is also same, sender, or we can say designated bridge ID. If designated bridge ID is same, then switch will check what? Then it will check lowest designated port, right? Or we can say sender port. Fine. Let's say here I have switch. Right? Or let's say we have single switch whose MAC address is 0A. And this port is 0/1. This port is 0/2. So now, guys, here root bridge ID 32768 plus 0A, cost 0, and the designated bridge ID means sender bridge ID 32768 plus 0A, because root bridge is sending the BPDU. Fine. In the same way, on this port, also. All informations are exactly same. So in this scenario, switch cannot select best path on the basis of these three information. Then switch is going to check sender port ID. So BPDU is going to carry one more information here, that is sender port ID. Sender port ID will be what? The port ID in STP, priority plus interface ID. So 128 plus 128 plus 1 interface dot 1, right? Port ID over here 128.2. So tell me which one is the best, where it is receiving best BPDU, where it is receiving BPDU on the on 0/1 interface again, right? Because here STP port ID is lower than the port ID of this BPDU. But guys, scenario can be different also. Like let's suppose here I have one switch 1, then this switch is connected with one hub. This switch is connected with one hub. And then another switch 2. Switch 2. In this scenario, here I have one link, here I have, let's say, 2 link. The base MAC address of switch 1 is 0A, and the base MAC address of switch 2 is 0B. Which switch will become root bridge? Which switch will become root bridge? Switch 1? RB, right? It will generate their BPDU. In the BPDU, root bridge ID will be 32768 plus 0A, right? Cost will be 0. Sender bridge ID will be same because it is root bridge. 32768 plus 0A. What will be the designated port? Let's say 128.1, right? Or it can be 0 if this is 0/0 interface. 1. 0/1. Right. Switch 1 is going to forward this BPDU to guys hub. It is going to forward this to hub, and hub will do what? Hub will perform broadcast. It will forward one BPDU from this port and one BPDU from this port. Now again, switch 2 is receiving BPDU on both port, same BPDU on both port, and all informations are same, right? Let's say this is my 0/1 interface and this is 0/2 interface. Now how switch 2 is going to select best path, best port on the basis of receiving port ID, right? So if designated port ID is also same, I'm writing here, the fourth thing is receiving port ID, right? So if sender port ID is same, then switch will check receiving port ID. This is the best path selection, and receiving port ID can never be same, right? Is it possible to have same interface ID of 2 port? No, that is not possible, right? So this is the best path selection in STP. Clear, guys, to everyone? Clear? Any question? Any doubt till here? No. Yeah? Priority of port. That is the priority, bro. By default, priority is 7 bits value, 7 bits decimal value, right? All spanning tree protocol will have one port ID. So spanning tree, see the port ID of 0/0 is 128.1. Port ID of 0/1 is 128.2, like this, right? So on the basis of port ID also, switch is going to select best path or best port. But when it will use the port ID, guys, if the root bridge ID is same, the cost is same, and the sender bridge ID is same, then it is going to check sender port ID. If sender port ID is also same, then it is going to use receiver port ID. Now the port roles in STP, very important. So we have some types of port in STP. As I told you, a spanning tree protocol is going to block alternate path, backup path, to avoid the loop, right? So there are some port role, right? One type of port is root port. Root port. The second type of port is designated port. Designated port. And the third type of port is alternate port. Right? Guys, a port whose role is root port will be always in forwarding state. The port whose role is designated will be always in forwarding state, but the port whose role is alternate will be always in blocking state, right? So the backup or redundant path will always get port role what? Alternate. Now question is, what is root port? So the port, or we can say a port which receives superior BPDU, right? Or you can say the best BPDU, or you can say the lowest BPDU, best BPDU, right? Then the designated port, a port which transmit superior BPDU, that port will become what? Designated port. And guys, the port whose role is not designated, not root, will become what? Alternate port. And the main concept is, on one switch there can be only one designated port. We cannot have more than one designated port on one switch. This is the port to reach root bridge, right? Port to reach root bridge. Like guys, in this scenario, see, switch 2 will receive superior BPDU on which port? On 0/1 or on 0/2? On 0/1, cost is 100. On this port, cost is 200, right? So it is receiving superior BPDU over here. So this port will become what? RP. RP is the port from which non-root bridge switch will reach to root bridge. If there are two RP, that means still there is loop. If there are two paths available to reach bridge, root bridge, that means there is loop in the topology, right? So one switch will have only one RP port. Now, in this scenario, which switch is sending superior BPDU? Root bridge switch, because root bridge switch is generating BPDU, right? With cost what? 0. So all ports of root bridge is sending superior BPDU, best BPDU. That means all ports of root bridge switch will be always what? DP. If we have 1000 number of ports on root bridge switch, all ports will have role what? DP. On switch number 2, one port will become RP and this port is the RP port, right? On switch number 3 also, one port will be RP and this port will be RP. Now guys, on this link we need to identify which port is the DP port. Automatically you can find the alternate port, because on switch number 2 we cannot have more RP. On switch number 3 we cannot have RP, right? So we need to identify which port is sending superior BPDU, this port or this port, right? This port or this port. Let's say this is the interface 0/2 and this is the interface also 0/2. Now can you tell me which port is the DP port? How? See, switch 2 will also send BPDU, switch 3 will also send BPDU, right? In the BPDU, root bridge ID will be 32768 plus 0A. Here also 32768 plus 0A. Cost will be guys 100 over here also, 100 over here also. Then the sender bridge ID 32768 plus 0A. Here 32768 plus 0C. Now which switch is sending superior BPDU? Switch number 2, right? That means this port will become what? DP. And on one link we cannot have more than one DP. On one link we cannot have more than one DP, right? So definitely this port will become what? Alternate, right? And if this port is the alternate port, so a status of alternate port is blocking. That means a spanning tree protocol is going to block this link. So guys, my logical topology is switch 1, switch 2, switch 3. Links are like this. Now can loop form here? Never. Am I right? This is how a spanning tree protocol is going to avoid loop in the topology. All clear? Anyone have any question? Please ask. If no question, guys, please let me know. Designated port is the port which transmits superior BPDU. RP is the port which receives superior BPDU. On one switch we can have only one RP, and on one link we can have only one DP. Like you can see on this link we have DP here, right? So that's why this port is the RP port. Guys, switch 1, switch 2, switch 3, switch 4. Switch 1 has MAC address 0A. We have link here. We have one link here. We have one link here. We have one link here. One link here. And one link here. 0A, 0B, 0C, and 0D. Tell me which switch will become root bridge. This is switch 1. 1, 2, 3, and 4. This is 0/1 on switch number 1 also, and on switch number 2 also. This is also 0/1 on both switch. This is 0/2. This is also 0/2. This is 0/3. And this one is 0/4. Yeah. Which switch will become root bridge? Switch 1 will become root bridge. Root bridge. Now the all ports of switch 1 will become what? DP. This port is also what? DP. This port is also what? DP. Now guys, what you need to find? RP on all non-root bridge switch. So tell me the RP port on switch 2. Switch 2 is receiving BPDU on multiple port, on this port also, on this port also, and on this port also, right? Where it is receiving superior BPDU? 0, 1 and 0, 2. So this port is the RP port. RP. On switch number 3, RP. On switch D, 0/4. RP. Fine. Now see, on switch number 2, you need to find the port role of 0/2 and 0/3. So what will be port role of 0/2? What will be port role on 0/2, guys? This port cannot be RP. Either this port can be DP or alternate. So this port will be DP because it is sending superior BPDU, right? Both switch 2 and switch 4 is sending BPDU on this link, right? But in the BPDU of switch 4, sender bridge ID will be 32768 plus 0D. Right? In the BPDU of switch 2, sender bridge ID will be plus 0B, lower sender bridge ID. So this port will become what? DP. On this port will become DP. On one link, we cannot have more than one DP. So definitely this port will become what? Alternate, because RP is already there, right? So this port is going to become alternate. Right? Now, link between switch 3 and switch 4. Where is the DP? On switch 3 or on switch 4? Guys, again, switch 4, bro, when switch 4 will send BPDU over here, the BPDU, sender bridge ID, cost is same, root bridge ID is same, then it will check what? Sender bridge ID. Sender bridge ID of switch 3 is lower, na? So this port will become what? This port will become DP, right? And on this port will become DP, this port will become what? Alternate. Alternate. Now on this link between switch 3 and switch 4, this port is DP port because of sender bridge ID, and this port is alternate port. Alternate port. So my loop free topology is, guys, see, we have one link here, one link here, and one link here. That's it. Rest all links are in blocking state. Now, if this port will goes down, what will happen? Now switch 2 is receiving superior BPDU on which port? On this port or this port? This port, right? Quickly, this port will become what? RP, and this port will become what? DP. You are wrong. You're absolutely right, bro. I am just joking. Okay. So now my loop free topology is this one, like this. Done. In my scenario here, which switch is the root bridge? If you want to see the MAC address of the switches, let me show you the MAC address of switch 1. Enable. So spanning tree, the MAC address of switch 1 is this one. Copy and let me paste over here. Is it visible? Fine. And the MAC address of switch 2 is 200. So which switch is root bridge switch? First one, right? So all ports of switch 1 will be DP. You can see all ports are designated port, right? And state is, guys, forwarding, and cost is 100 because these are Ethernet port. On switch number 2, which port is the RP port? Which port is the RP port? It is receiving BPDU on both port. Where it is receiving superior BPDU? Cost is, root bridge ID is same, cost is same, sender bridge ID is same, then sender port ID 0/0, right? So to verify it, here I can say, so spanning tree. So you can see the RP 0/0 is root port and 0/1 is alternate port. Fine. So only one link is working between switch 1 and switch 2. Switch 1, switch 2, switch 3, and switch 4. 2 links are there. If you can solve this topology, that means your STP election is clear. Switch 1, MAC address is 0, A. Switch 2, MAC address is 0, B. Switch 3, MAC address is 0, C. And switch 4, MAC address is 0, D. This is 0/1, 3, 4, 5, 6, 5, 6, 1, 2. Three, 4. Now can you tell me, guys, loop free topology? Anyone can tell me the loop free topology? Like here I'm going to design loop free topology. You only need to tell me the link, like port ID between switches. Switch 1, switch 2, switch 3, switch 4. This is the physical topology and this is my logical topology. Now tell me the logical topology. Will I have any link between switch 1 and switch 2? Then which port? Which link? Zero 1. Okay, 0 1. Will I have any port between switch 2 and 4? Guys, to check is link active between switch 2 and 4, what you need to check? You need to check only the RP port, because on non-root bridge switch there will be only one RP. On all non-root bridge switches there will be only one RP, right? Is there any link between switch 2 or 4 or not? This is my question. Yes. Okay, which link? 0/3. Is there a link between switch 1 and switch 4? If yes, then bro, still there is loop. Yeah, then there is loop. This is not loop free topology. Very good. Very good. Here we will have one link that is 0/5 and here I have one link that is 0/3. This is my loop free topology. Is it clear to everyone, guys, how I have designed loop free topology from this physical topology? Anyone have question? If it is not clear, please tell me. If it is not clear to anyone, please tell me. Otherwise, I will move. Still not clear? Still not clear. Designated port, root port. Root port is the port on these switches only. Okay. On this switch, my root switch 1 is the root bridge switch. Is it clear? So all port of root bridge switch will become what? DP. Clear? DP, 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 and DP. Now on switch number 2, which port will be RP? Bro, switch 2 is receiving BPDU on 6 interfaces, right? On this port, 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 as well as on this port, where it is receiving superior BPDU. To identify superior BPDU, first you are going to check what? Root bridge ID. So root bridge ID in all BPDU is same. Then you are going to check cost, right? So cost on this link is 19 or 100. If it is Ethernet link, 100. Cost on this link is 200, 200, 200, 200, right? Clear, bro? Right? That means on these two ports, costs are lower than these ports. So definitely these ports are not going to become RP, right? So out of these two ports, now we need to identify which port is the RP. So if cost is same, then you are going to check what? Sender bridge ID. Sender bridge ID will be also same because both ports are connected with root bridge directly. Then you are going to check what? Sender bridge, port ID, right? Lower port ID will be preferred. So on this link, port ID will be 128.128.2, over here 128.3. So this port will become what? RP, because here we have lower designated port ID, sender port ID than this. So this port is going to become RP. This port, alternate, because on one switch we cannot have more than one RP, right? And on this link DP is already there. So definitely this port will be alternate port. Correct? Now on switch number 3, which port is the RP? This port? Because on these ports cost is 200, on these two ports cost is 100, right? So out of these two ports, one port will become RP. To identify which port is the RP, we are going to check next parameters. Sender bridge ID. Sender bridge ID is same than sender port ID. Sender port ID over here is lower, so this port is the RP port. So this port will become what? Alternate. On switch number 4, again here cost is 200, here cost is 200. On these two port cost is 100. So out of these two port, one port is going to become what? RP. Now which port will become RP? For that, what we are going to identify? We are going to check the sender port ID. So sender port ID on this link is lower than this link. So this port will be RP and this port alternate. So this is how I have calculated the loop free topology, right? I have one link here, that is 0/1. I have one link over here, that is 0/3. I have one link over here, that is 0/5. Clear? Now guys, by default, loop free topology is this one. Fine. So if there is one PC here and I have another PC over here, if these two PC want to communicate with each other, how they will communicate? Via switch 1, via root bridge only, right? But the admin told you to configure the scenario in such a way so that these devices should communicate like this. Switch 3 should forward traffic to switch 4. What you can do? How you can manipulate the path? How you can manipulate the path, guys? Am I audible? Yeah. I want to use this link, not this link. Port parity or cost? No. See what will happen if I will, where you will increase the port parity, on which link, on which port, on switch number 4, on switch number 3, where you are going to increase the port parity. Guys, do you think any switches has select their best port with the help of port parity? Hello. Yes, bro. Out of these link, one link is the RP on the basis of port parity only. Port parity of sender switch, designated port ID, right? So even if I will configure here port parity, higher port parity or lower port parity, do you think this path will become best path? This path? No, because cost over here is 200 and cost over here is 100. When switch is going to check port parity, when cost will tie, then switch is going to check what? Port parity. So switch 4 is going to check port parity between these two link, not between this link and this link. Yes. Yeah, definitely we can change cost. We can change port parity as well. Like if I want to manipulate path between these two link, then definitely I will use what? I can use port parity as well. I can use cost value as well, right? But when these link and these link, I cannot use port parity because it will not check port parity. It will select the best path on the basis of cost only. Yes, Vezad. Correct, correct. So yeah, very good. First option is we can change the root bridge. So if I will configure here parity 0, guys, what will happen? Switch 1 will become what? Root bridge. Then these all ports will become DP, 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 right? On switch number 4, which port is the RP? This port, right? Now this link between switch 3 and switch 4 is active, right? On switch number 2, this port will become RP. On switch number 1, this port will become RP. So now your loop free topology is this one, right? So simply we can make switch 3 as a root bridge switch. This is the reason why we have priority, right? By default, switches are electing root bridge on the basis of lower MAC address because by default priority is same. Then why we have even concept of priority? This is the reason why we have priority, to manipulate the root bridge, right? Let's say switch 2 is the main switch, right? Root bridge should have more memory than non-root bridge switches because root bridge switch is going to generate BPDU after every 2 seconds for all the ports. It is going to manage database. It is going to even manage entire topology, right? So with the help of priority, we can manipulate the root bridge. Now, bro, if you are not allowed to change root bridge, then if you are not allowed to change root bridge because this switch has best CPU, best memory, right? So you cannot configure switch 3 as root bridge. In that scenario, how you are going to use this link? Cost. So guys, if I will increase the cost on this link, if I will set cost 200 over here, will it work? Will it work? Again, it will not work. It will work. Now switch 4 is receiving BPDU on these ports also and on these ports also. So which port will, huh? Port ID, it will work. Here I have set cost 200. Now cost on all link is same, 200, right? So now switch 4 is going to check what? Sender bridge ID. So sender bridge ID of switch 2 is lower than switch 3. So this link will be in forwarding state, not this one. Clear? Switch 2 has lower bridge ID, so this port will be in forwarding state, not this one. So you can do one thing, you can set cost over here 300, here 300, right? Then automatically these two ports will become best port, and out of these two ports, one port will be RP. So guys, if I will configure cost 200 on this link, then this link will come in forwarding state. this link. So what we can do, we can decrease some cost over here, right? So if I will set cost, let's say 99 here, 99, then switch 3 is also sending BPDU, switch 2 is also sending BPDU, switch 2 is sending BPDU with cost what, 100, and switch 3 is sending BPDU with cost what, 99, right? This port will be the best port. Now it is not going to check what, sender bridge ID, designated bridge ID. Clear? This is how we are manipulating the path in spanning tree protocol. And scenario can be anything. Interviewer can ask you any scenario, like I want to use, let's say, this link, like this should be my loop free topology, not like this is not loop free, this. And even switch 1 should be the root bridge, we can, right? Or they can say my topology should be like this. Yes, possible. Or my topology can be like this. Yes, possible. Right? So with the help of priority, we can manipulate the root bridge. With the help of cost, we can manipulate the path. And with the help of guys, port ID, we can manipulate the port. And see the another option, like here I have set cost 200, right? Now this port is the best port, forwarding state, right? So what we can do, we can decrease some priority over here, right? By default priority over here is 32768, 32768. If I will configure priority 100 over here, what will happen? Automatically this switch will start receiving superior BPD over here on these ports, not on these ports. Earlier switch 4 was selecting best port on the basis of MAC address of switch 2 and switch 3, right? Now it will select best path on the basis of priority. So on non-root based switch also we can change the priority, right? And for the backup, we can configure one switch as a primary root bridge and one switch as a secondary root bridge. So you have to configure switch 1 priority lower than the priority of switch 3. Yes. Then I have to configure lower priority on switch number 1 than 100. Otherwise switch 3 will become root bridge switch. So let's suppose switch 1 priority is 0. Switch 3 priority is 100, like that. Now the STP states. Now we'll discuss about the secondary primary later. STP states. So guys, we have some states over here like disable. First state is disable. The second one is blocking, listening, learning, and forwarding. Okay. Disable means the shutdown. Disable means the port is shut down. The STP states start from blocking. Whenever a port will come up, when you will run no shut command, or a switch will come up, also will power on the switch. The first state in spanning tree protocol is blocking, right? Disable means if the port is down. Administratively, engineer has run shutdown command, right? In that scenario, you will see the STP state is disable. Now, why we have blocking state? Guys, just because of blocking state only we are going to avoid what? Loop. Otherwise, it is not possible to avoid loop. So whenever a port will come up, first it will goes to blocking state. First it will goes to blocking state to avoid the loop. Correct? Blocking port does not forward data. Blocking port only listen for BPDU. Blocking port, let me write here. Blocking port does not forward data and only listen for for BPDU, right? Bridge protocol data unit. So guys, whenever a port will come up, first port will enter in blocking state, and then quickly it will move to the learning state if the port role is DP or RP. If the port role is alternate, then port will be keep in blocking state. Then whenever a spanning tree port will come up in STP, their state will be blocking. If their port role is DP or RP, then role will quickly move to listening state. But if the port role is alternate, then port will be in the blocking only. It cannot move to the listening state, right? So like in this scenario, when I have enabled the spanning tree protocol, let's say on switch number 3, both port will be in which state? In the blocking state. And in the blocking state, it cannot forward the data. It can only listen for BPDU. Fine. Now guys, in listening state, port is going to spend 15 seconds. The port prepares to forward data but cannot forward the data. Port is preparing their self for forwarding the data, but still port is not allowed to forward the traffic, right? It cannot forward the data. And in the blocking state, as I told you, blocking state cannot send the data, cannot receive the data, cannot send the BPDU, can only receive the BPDU. Listening state can again not send the data, cannot receive the data, right? Even it cannot learn the MAC address. Blocking port can also not learn the MAC address, but in the listening state, port can send the BPDU as well as it can receive the BPDU. Send the BPDU as well as it can receive the BPDU. Now guys, I have one question, right? Let's suppose I have turned on switch number 3. So this port will enter in which state? In blocking state. In the blocking state, then how it will send the BPDU? If it cannot send the BPDU, then how switch number 1 will get to know which one is the root bridge? If switch 3 has priority 0, right? So switch 3 should be root bridge. Or let's say switch 1, when this port will come up, how it will send the BPDU? If the state is blocking. Yeah, tell me guys, what is the answer? So whenever a port will come up, for the first time it will think I am the root bridge. Switch will think I am the root bridge, right? So they will consider their port as a DP, designated port, right? So port will quickly move to listening state. In listening state, it will prepare their self to forward data, right? But it cannot forward the data, so it will send what? BPDU. It will send BPDU, right? Switch 3 will also send BPDU. It will compare their BPDU with the received BPDU, right? And it will perform the election. The port is going to become RP or DP or alternate. If this port is transmitting superior BPDU, then this port will be in DP only. If this port is receiving superior BPDU, then this port role is going to be RP. And guys, if this switch is receiving superior BPDU on any another port, then that port will become RP, right? So this port is still sending BPDU, right? As well as receiving the BPDU. So it will compare. RP is already there. It will compare. I am sending superior BPDU or receiving superior BPDU. If I am receiving superior BPDU, that means my port is alternate. And again, a state will move from listening to blocking. Clear? Again, port will move from listening to blocking. This is the benefit of blocking state here. If we don't have blocking state, there can be loop, right? So in the listening state, switch is going to spend 15 seconds. Can it learn MAC address? No, can't learn MAC address and can't send data, only sends BPDU. Then learning state. In the learning state, switch can learn the MAC address. Again, it is going to first spend 15 seconds here in this state. 15 second, right? Can learn MAC address. Can note sends data. Can sends BPDU. Right? And till learning state, port have to decide their port role, right? So either port role can be alternate. So if the port role is alternate, again status will move to blocking state. If the port role is DP or RP, then state will move to forwarding state. And in forwarding state, port can forward the data. It can learn MAC address in the MAC address table, and it can send the BPDU. Clear? So blocking state means what? What do you mean by blocking state? Actually, we are saying blocking state means a port is waiting. Blocking means waiting port, waiting for the port role, and does not forward any data frame. It only, even it cannot send the BPDU. It can only listen the BPDU. Like in my scenario, switch 1 is the root bridge, right? And between guys switch 1 and switch 2, which port will be in forwarding state? 0/0, right? 0/1 of switch 2 will be in blocking state. So it can only receive the BPDU. It cannot send the BPDU, right? So switch number 2 is receiving BPDU on both port, on 0/0 as well, on 0/1 as well, right? So if 0/0 bill goes down, fine. Switch is receiving still BPDU on 0/1 also on the blocking state, right? If the port 0/1 is the up, then it is receiving superior BPDU on 0/0. But if 0/0 is down, then switch is receiving only one BPDU, right? Over here, 0/1 only. So that will become the best. Even it is receiving on these ports as well, like but here the cost is different, more than this link, this port. So interviewer can ask you like there are two switch, two PC, and just I have come up the switch, I have power on the switch, and these ports are in blocking state. Can these two PCs communicate with each other? Answer is no. After some time, we have seen the port is in listening state. Can these two PC communicate with each other? Again, no. After 15 seconds, this port is in learning state. Can this PC communicate with each other? No. Right? So to communicate with each other, PCs have to wait for 30 seconds. So they can ask you like why these PCs are not able to communicate with each other for first 30 seconds. So guys, just because of STP states, right? So see, if I will power on this device, in which state? Listening state. Still in listening state. Now in learning state, right? Still in learning state. So now PC cannot communicate. PC have to wait for 30 seconds. Now you can see port is in forwarding state. So only forwarding state ports can send the user data, right? Or the frame, you can say. Then they can ask you why we have blocking state. So guys, to prevent the loop. Purpose of blocking state is to prevent the loop from happening. If a loop is detected, the blocking port will be not forwarding any user data. Listening state means listening. See, it is clear with the name, listening. The port begins to listen to the traffic, to the network traffic. Or you can say the initialization to listen the network traffic, but still does not forward any data frame. Actually, in the listening, yeah, listening state. Whenever change will occur, again user have to wait for 30 seconds. Every time STP need 30 seconds to converge the topology. Once any link will goes down, all switches are going to put their ports in blocking state first to avoid the loop. If any link in the network will goes down, all switches are going to put their all interfaces in blocking state. Again, it will perform RP selection, DP selection, alternate port selection. Okay. In the listening state, actually switch is trying to find out their port role, whether it will become RP or it will become DP. That is the main purpose of listening state, right? It is trying to find their port role. And port role, see, the port role will be decided in listening state only. Port role is going to be decided in listening state. That's why all ports are going to spend 15 seconds. But you know, we can change this timer. This is the default timer, 15 seconds. When port is shut down, when you have run the command no shut down, STP is enabled on a port, but port is down, or their line protocol is down. In that scenario, you will see the state is disabled. Right. So guys, in listening state, ports are going to figure out their role, and they are trying to check the loop if any loop is there. If the port role will be DP or RP, then state will move to learning, otherwise state will move to blocking. In the learning state, actually port starts learning MAC address. Ports start learning MAC addresses. The source MAC address. But again, in the learning state as well, switch cannot forward the data. It can only learn the MAC address. Let's say the port role of this port is learning, and in that time PC1 is sending any data. So this switch can learn MAC address in their MAC address table, but it will not forward the data. It will drop the data. Sometimes interview is asking these types of questions from the state. It is important for the interview. That's why I'm taking time here. Okay, so if someone asks you like purpose of learning state, you can say purpose of learning state is building the MAC address table, so that when port will be in forwarding state, switch will be ready to forward the data, and switch knows where I need to forward this data. And this state also takes 15 seconds. So total time taken by a port to come in forwarding state is 30 seconds in spanning tree protocol. And if the port is completely turned off, then state is going to be disabled. Clear guys? Port role is clear? No, I said it can learn the MAC address. See here, in the learning state, can learn MAC address. In the listening state, can't learn MAC address. In the blocking state, can't learn MAC address, can't send the BPDU, right? So in the blocking, even it cannot send the BPDU, it cannot send the data, it cannot receive the data, it cannot learn the MAC address. Listening also, the difference between the blocking and listening is the listening state can send the data, send the BPDU, right? Rest all is same. In the learning, it can learn the MAC, it can send the BPDU, but it cannot send the data. Then we have what forwarding. Yeah. Where? In which state? Can't send data, only send BPDU, send and receive. Send. Okay. Blocking can only listen for the BPDU, can only receive the BPDU. Only listen for BPDU, cannot send the BPDU. In the listening state, the main purpose of listening state is port election. cannot send BPDU. Now guys, the next topic is topology change. Topology change in STP. The default behavior is clear, right? Now we need to understand what will happen, how switches are going to reconverge the topology whenever change will occur. Now in this scenario, can anyone tell me the loop free topology? Switch 1, switch 2, switch 3, switch 4. Loop free topology. Will I have any link here? This is the loop free topology, I think, if I'm not wrong. Right? Now guys, we are going to understand what if any link will goes down. Let's say if this link will goes down, then the loop free topology is going to be different, right? There are many loop free topology here, right? Like loop free topology, switch 1, switch 2, 3 and 4. Again switch 1, switch 2, switch 3, switch 4, switch 1, switch 2, switch 3, switch 4, switch 1, switch 2, switch 3, switch 4. I can have this topology, I can have this topology, right? I can have this topology, I can have this topology, sorry, this one. Like this, we can have many topology, right? Even over here, either I can have 0/0 or 0/1. So whenever change will occur, how topology will converge? Guys, to understand the topology change in spanning tree protocol, first of all, you have to understand the topology change. So there are many type of topology change, right? Like we have insignificant topology change. Significant, I'm saying TC. TC means topology change. We have direct topology change. Direct TC. We have indirect topology change. Indirect TC. So whenever an access port of a switch will goes down or come up, that type of change is known as insignificant topology change. See, by default, a spanning tree protocol is running on LAN port also, right? The port which is connected with PC. And guys, if a spanning tree is running over here, that means switch is sending BPDU over here as well. It is sending BPDU to PC as well. But PC does not need any BPDU. Right? So like in routing protocol, we are doing what? We are configuring passive interface. In the same way here, we can enable port fast feature. Port fast to disable BPDU on LAN port, on the access port. Right? Switches should send BPDU on the trunk port only. It should not send BPDU on access port. This is the access port. These are the trunk port, trunk link. Right? As a spanning tree is running over here, so if this port will goes down, or if I will add one PC here, this spanning tree protocol will consider it as topology change, and again it will take 30 seconds for the convergence, right? So whenever you will add a PC on switch, or whenever you will receive a PC on switch, there will be no communication for 30 seconds. There will be no communication for 30 seconds. PC1, I'm saying no, port fast is different thing. Port fast is used to stop BPDU on the access port. Stop BPDU on the access port 10.1.1.2/24. From PC number 1, ping 10.1.1.2. Ping is working. It will be keep pinging. Now if I will add any PC over here on any switch, you will see these devices are not able to communicate with for 30 seconds. Or guys, on switch number 1, 0/1 is in blocking state, correct? It is in blocking state. So I'm going to down blocking state port. Interface E0/1. This is in blocking state, says shutdown. See. Ping is still working. How ping is still working? It should take 30 seconds to convert the topology. First of all, guys, whatever things we have discussed till now, that is CST. See, there is some difference in the spanning tree protocol behavior according to their type. So this is CST, common spanning tree protocol, and the protocol which is running on switch is so spanning tree summary. Which protocol is running? Which protocol is running? PVST. PVST is a Cisco proprietary protocol, right? You cannot run this protocol on non-Cisco devices. This is for Cisco only, right? So protocol is the CST. If any port will goes down, anything will changed. Any change will occur in the topology. All switches are going to take 30 seconds to convert the topology. So spanning tree protocol. All ports are in forwarding state, and interface is 0/1. I'm going to say no set, no set, and so spanning tree. This port is in non-listening state. This is the incorrect output here. No worry, I will tell you about the topology change. Whenever change will occur, STP will take 30 seconds, right? Even when I will add or remove a PC. So first problem is how to overcome this issue. Like whenever I'm adding a PC or removing a PC, STP is going to take 30 seconds. Because what will happen? Once I will add one new PC here, that means one new port will come up in a spanning tree protocol. Right? That means there is some change in STP. And whenever change will occur in the spanning tree protocol, all switches are going to reconverge the topology. And whenever topology will reconverge, it will put all interfaces in blocking state. In the blocking state. And from blocking to forwarding, a port need how much time? 30 seconds. Because there are two more state, listening and learning, and both are going to take 15 seconds. A port from listening to learning, a port can move from listening to learning after 15 seconds only, right? Doesn't matter that they are going to do something or not, they are free or not, port is elected, elected or not. Even if port is elected, like this port will be the DP, or this port will be the RP, then also it will wait for 15 seconds. After 15 seconds only a state will move. Or maybe in this topology I have already configured the features to reduce the time, right? So we have multiple features, guys, to reduce these timers. Like one feature is port fast. Port fast will overcome this issue. Then second type of topology change is direct topology change. So if RP port of a switch will goes down, an alternate port is available. If RP port of a switch will goes down and alternate port is available, that type of change will be considered as direct topology change. So this switch is the root bridge. That means their all ports are DP, 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 DP. Right? This port is, guys, RP, this port is RP, and this port is RP. On switch number 4, which port is the alternate port? This port. This port is the alternate port. On switch number 3, this port is the alternate port. On switch number 2, DP, DP, and this port is alternate port. So is there any port, any switch, guys, where we don't have alternate port? Yes, only root based switch. So if the RP port of switch 3 will goes down, that type of change is direct topology change. But if the DP port of switch 2, this port will goes down, that type of change is called indirect topology change. What is the difference between direct topology change and indirect topology change? Guys, indirect topology change needs 15 seconds to convert the topology, and direct topology change need 30 seconds to reconvert the topology. So we are going to see how indirect topology change need, direct topology change need 30 seconds. Extremely sorry. 30 seconds. Direct topology change, right? So here you have to understand why we need 50 seconds, right? And interviewer can also ask you, like, why we need 20 more seconds here, right? So before talking about this, we have to understand the timer, like max's time, In the BPDU you had seen, right, there was hello time, message time. So a spanning tree one, message time is 20 seconds. Now the last question is, this port is in forwarding state, this port is in forwarding state, and this port is in forwarding state. Now guys, this port is in blocking state, means alternate port role, right? That means it is receiving the BPDU over here. If this link will goes down, definitely switch 4 will discard the BPDU immediately. It will discard the BPDU immediately because their on interface is going down, right? So their line protocol will goes down. If the line protocol of interface will goes down, it will remove all the MAC address, right? On the router as well. If their line protocol will goes down, it will remove all the routes available on that interface. In the switch, if their line protocol will goes down, it will remove all the information on that port. Means it will remove the BPDU as well, right? But what is the difference between hello time and hold on time? Hello time is the specific interval of time after that devices will sending the hello message, and hold on time is the time till when device is going to hold that information. Time till then device is going to hold that information. So if I am sending you one hello message to you and the hold on time is 10 seconds, so you are going to store that information for 10 seconds, correct? So message time is nothing but the hold on time, right? So now guys, let's suppose here scenario is bit different. The scenario is, this is the forwarding state, this one is the forwarding state, and this is the forwarding state, right? This port is the alternate port. Now if this link will goes down, what will happen? Switch 4 will not receive BPDU over here, right? But in this scenario, switch 4 is not going to discard the previous BPDU immediately, right? So still for 20 seconds, best BPDU is the BPDU over here on 0/0 only, yes or no? After 20 seconds, it will discard the BPDU. Then now it is receiving one BPDU over here. So after 20 seconds, BPDU on this port will become what? Best BPDU. For 20 seconds, it will be forwarding traffic from this port only. So that's why we need 20 more seconds in case of that topology change. Don't worry, there are many some more concept in topology change. We'll discuss that tomorrow. Till then, let me show you a few commands, like to change the what priority on switch. To configure priority, what we can do, we can say a spanning tree. Then for VLAN, why for VLAN? Because I'm running PVST, per VLAN a spanning tree, right? So for VLAN 1, and then I can say priority, whatever priority you want to configure here, but increment should be in this 4096 only, right? So I can configure the 0, I cannot configure 100. See, priority can be this one, 0, this one, this one, this one, this one, like this till here. And by default priority is this one. Fine, this is the first command. Then interface is 0/0. Then I can say a spanning tree for VLAN 1, and then cost, right? So see the range of cost on this device here. We can configure the cost. The by default cost is, for Ethernet by default cost is 100. For fast Ethernet 19. Actually this is just because of the bandwidth. If bandwidth is 100 Mbps, then cost is going to be 19. So like this we can change the cost and port priority. So see the range of port priority, and it should be incremented of 16. So we cannot configure like 8, right? It can be either 0, 16, like that. 60, like this. And so a spanning tree, cost of 0/0 is, guys, 100. If cost is 100, so interface is 0/0 include bandwidth, because bandwidth is 10 Mbps. So if I will change the bandwidth, interface is 0/0, I'm saying bandwidth, few more 0 here. Now so a spanning tree, cost is what now? 4. So cost does not depends on link type, cost depends on link bandwidth. Getting my point? right? And now see guys, I have changed the bandwidth, so cost is also changed and port priority is also changed. But I don't know the formula to calculate cost and priority. Even you can spend some time on internet to find the formula. So we have topology change, and then I think in a spanning tree protocol we have covered everything. After that we'll see the types of STP. So guys, if I will talk about the types, so we have first CST. We have already covered this. Then we have PVST. This is Cisco proprietary, right? Then PVST plus. Then RSTP. And nowadays we are using this one only. RSTP. Then RPVST. Cisco have again designed their protocol. And after that we have what? MST. So either we are using RSTP or MST. In most of the scenario we are using RSTP. The reason? RSTP is a fast in convergence as compared to PVST, CST, PVST plus, right? And for the load balancing, we are using MST. Okay.